Hello everyone, I'm Prajwal S. Gowda, pursuing my engineering in Sri Venkateshwara College of Engineering, and today's topic is brute force approaches of analysis of design and algorithm, subject code BCS 401. Brute force approaches. Introduction to brute force approaches. Brute force approaches refer to problem-solving techniques that systematically enumerate all possible solutions. These methods are often simple to implement but can be inefficient for large datasets. They are widely used in areas such as cryptography, optimization, and algorithm design. What is brute force? Brute force is a method of solving problems through exhaustive search. It involves generating all possible configurations or solutions to find the correct one. This approach guarantees a solution if enough time and resources are available. Characteristics of brute force approaches. Brute force methods are typically easy to understand and implement. They require no advancement knowledge of algorithms. These methods often lead to high computational cost, especially with large inputs. Types of brute force approaches. There are several types of brute force approaches, including exhaustive search and trial and error. Each type varies in its execution but shares a core principle of checking all possibilities. Common applications include password cracking and solving combinational problems. Applications in cryptography. In cryptography, brute force methods are used to crack encryption, encryption keys. Attackers systematically try every possible key until the correct one is found. While effective, this approach can be mitigated by using stronger encryption algorithms. Applications in optimization. Brute force can be applied to optimization problems to find the best solution among all possible solutions. Examples include the traveling salesman problem and scheduling tasks. While brute force guarantees an optimal solution, it may be impractical for large data sets. Advantages of brute force approaches. One major advantage in their simplicity and easy of implementation. They provide a guaranteed solution as long as the problem is solvable. Brute force methods are versatile and can be applied to various types of problems. Disadvantages of brute force approaches. The primary disadvantage is their computational inefficiency for large problems. They often require significant time and resources, making them impractical in real-world applications. Additionally, the exponential growth of possibilities can lead to a combinatorial explosion. Time complexity of brute force and space complexity of brute force. The time complexity of brute force approaches typically grows exponential with input size. This means that as the problem size increases, the time required to find the solution increases dramatically. Understanding the time complexity is crucial for evaluating the feasibility of brute force methods. Space complexity refers to the amount of memory required for brute force approaches. In many cases, brute force methods require storing all possible solutions or states. This can lead to high memory consumption, especially in large-scale problems. Real-world examples of brute force. An example of brute force in action is a password attack where every possible combination is tried. Another example is a brute force solution to the knapsack problem. These examples highlight the practical implementation and limitations of brute force methods. Alternatives to brute force. There are various alternatives to brute force, such as heuristic algorithms and optimization techniques. These methods can provide faster solutions without exhaustively searching all possibilities. However, they may not guarantee an optimal solution like brute force does. Hybrid approaches. Hybrid approaches combine brute force method with more significant algorithms. They leverage the strength of both techniques to reduce computation time. This can be particularly beneficial in complex problems requiring guaranteed solutions. Future of brute force approaches. Advances in computational power may make brute force methods more feasible for larger problems. Quantum computing cloud revolutionize brute force techniques, allowing faster solution search. As technology evolves, brute force may find new applications in emerging fields. Limitations in modern computing. Modern computing limitations still pose challenges for brute force methods. Security measures such as rate limiting can hinder brute force attacks. The need for efficient algorithms remains critical in addressing large-scale computational problems. Conclusion. Brute force approaches remain a fundamental part of algorithm problem solving. While they have limitations, their simplicity and guarantee of finding a solution make them valuable. Understanding both brute force methods is crucial for both developers and security professionals. This structured presentation covers various aspects of brute force approaches and should serve as a comprehensive overview of the topic. Thank you.